All right, 12B. So, what are you doing in 12B? Thank you. Exercise 12B, you're now looking at how to solve what we call systems of linear equations. Okay, sounds intense. All it is this is what you used to have to do in year 9 and 10 where you do it by hand. There would have been simultaneous equations and you would have done elimination method or substitution method. And then you learnt how to do it on a CAS. Now, we're going to apply that to matrices. Okay?
We have to do the thing where you solve a code.
Solve the...
A code. Remember we...
Yeah.
You had to solve a code.
Obviously,
There were 2 matrices and you had to solve the code. We have to do that.
I don't think so.
Does anyone know what I'm talking about?
Yeah.
Oh, the code.
Absolutely.
In year
Yeah,
9
the code.
exam, the code
Yeah.
something.
Like code.
Oh.
Code.
Yeah,
Coding.
okay, we don't have to do that.
I don't think so.
You get the code, you put in the door, and
I see. Sounds
So
exciting.
it's like numbers and then it reveals words.
Oh.
We don't-
No, I don't think so.
Just say
All right, here we go. Let's do this example. Let's do this together.
in the light.
Example 4. Thank you, Year 12s. Thank you. Settle down. Eyes and ears towards the board. I am recording, so I just want to make sure this is smooth. Thank you. Thank you. Yeah, I know. Till we're ready. Thank you. All right, 12B. Solving a pair of simultaneous linear equations. So you've learnt how to do this multiple methods. Your method for this example here is you're trying to use matrix methods. One of the best ways to do it in matrix first is you need to be able to represent it as a matrix. How it's done, you can see here you've got X and a Y, so you know that's going to be 2 terms that you're going to be working with. Now notice that there are 2 rows and then 2 columns. So that way, that's already a hint that you should be setting up with a 2 by 2 matrix. So here we go. I'm going to do a 2 by 2 matrix. So 2 rows, 2 columns. Now the key part is we're only interested in just the numbers. So I'm going to set it up. It is 3, 4, 2, 3. And those are the coefficients or numbers in front of the variable. So where does the X and Y come from? Notice that X comes first and then Y comes second. So that means in the order, when I do matrix multiplications, remember it is a 2 by 2. That means the next one has to be a 2 by something. By 1, because I have an X and a Y. So I need 2 rows, and that would make it X, Y. So X comes first because that was the order that I was working with. So X in the row, Y in the row. So now it becomes X in the column, Y in the column. So if you multiply this now, that should give you a 2 by 1 result. So the 2 by 1 result will look something like this now. So 2 by 1, so I'm going to write it again. This is a 2 by 1, and your result is meant to equal to 6 and 4. But 6 is the first one, and then 4 is the answer for the second equation. So that's why you would be putting a 6 and a 4. Okay? So what we see here is an equation. We see an equation where this matrix multiplied to this matrix should equal to that. That's just a representation of what you see up here. So you're not solving anything yet. Now, on a theoretical sense, your aim is to find out what X, Y is. Now, if I name them in terms of their matrices, you can look at it as matrix A multiplied to matrix X is equal to matrix, I don't know, let's call it C. Okay? So, technically, normally with algebra, to find out X, you would say then divide both sides by A. You can't. There's no such thing as division in matrices. If you notice from chapter 11, we never had a division. But what we did have, which is 12A, we had the inverse. So to get rid of this A, there was a way to get rid of A so that you get X by itself, because that's what you're trying to solve for. So to get rid of A, this is where the technique comes in. You would do A inverse multiplied to A, that's your identity matrix, that's 12A. Okay, so if you go back to 12A, this is where that theory comes in. But remember, balancing the equation, if you multiply A inverse on the left, then in your matrix, you will also have to multiply A inverse on the right. this is where this cancels out and you end up with x is equal to A inverse C. Now, if this, what I just explained, is too confusing, you don't need to know that. That was just me explaining where the formula comes from. So this formula is what you're seeing over here. See that? That section there? They're just trying to tell you, without showing you the mathematics behind it, is that you're trying to get rid of this A so that you can find out x. The technique mathematically is that you're finding the inverse of times A. That's the inverse of times A. So, as long as you can type in your calculator, what is the inverse of this matrix, A, multiplied to C, which is the result matrix, you should be able to find out the matrix X. So if I did it on my CAS, let's do this on a CAS, let's do it together. So here we go, I've already modeled it. So on my CAS, it seems like if I want to find matrix X, it is the inverse matrix of A multiplied to the matrix of C. So I'm going to type that on my calculator. So here we go. How you would do it, if you were starting off from scratch, I would simply go matrix, it's a 2 by 2, so I'll simply use this one. 2 by 2, 3, 4, 2, 3. Store it, call it A. Okay, so store it as A. I would then use the next one, and it's a 2 by 1. So 2 by 1 is 6, and 4. And I will store that as C. So here we go, store it as C. And all you have to do now, because you know X, matrix X has to be the inverse of this multiplied to C, then I can type now A to the power of -1. That's the inverse. So this is going back to 12A, exercise 12A. That's the inverse. Multiplied to C, that's my answer. So this tells me now, if I just go back here, and, sorry, let's do this again. If I go back here, we've got our answers are 2 by 1 to 0. But remember, the matrix X was XY is equal to 2, 0. So what this tells me is the X value. So if they said find out X and find out Y, X is equal to 2 and Y equals to 0. That's using matrix methods. Okay, now if you have other methods that you remember from year 9 and 10, you could have done also, you could have done menu, algebra, solve. You could have done that, menu, solve, and you could have typed the two equations in. So if I typed these two, and I said 3 times X plus 4 times Y equals 6, times Y equals 6, comma down, 2 times X plus 3 times Y is equal to 4, comma X, comma Y. That will also do the same thing, and it'll say X equals 2, Y equals 0. So that's what you would have done year 9, year 10 in terms of algebra. But now we're doing matrix solving. That's all you need to know. So this is the formula to find the X matrix. Okay, and that's all they're doing for each and every one of these examples here. That was a 2 by 2. This is another 2 by 2. And then you'll be doing a 3 by 3. So see over here, same techniques. If you were to write this, this is 3 columns. There's 1, 2, 3, 3 rows. So when you write it, you should have your matrix as 3, 4, -2. What's in the next row? Be careful with this one.
7.
Not 0. Because remember, X is in the first column, Y is in the second column, and Z's in the next one. So what should be here? 2, 3, and then 0. That's where 0 should be. Okay, so common mistake is that students will put a 0 there. Look at the variables. So we've got X, Y, then Z. So that means it's 2, 3, 0. And then the last one is easier. It's 1, 2, and 3. What's your X matrix? It's X, Y, Z based on the order they've given it to you. So X, Y, Z. That should give you the resulting matrix, -5, -1, 3. And again, you can do that on your CAS. Label it as A, label it as X, label it as C. Then your formula should then be X equals to A inverse times C. And you'll be able to get it. Okay? Now, in your textbook, there's one more skill that you need to know. So that was what I wanted to teach. There is a second skill in the methods course. They will go deeper into it, but you just need to know what they mean when they say, and I'm going to find that question for you. This question here, when they ask this one, which one of the following have a unique solution. Okay, so in the methods course, they'll say something like no solution, unique solution, and infinitely many solutions. Your case, you do only need to know when you have a unique solution or not. And you don't need to know anything besides the fact that unique solution, for you to understand this idea just as a sort of theoretical point, you're actually solving for a systems of linear equations. What does that mean? If you type this in your graph, it will end up being straight lines. Now, straight lines, you're finding the point of intersection. When you tell me what x is and what y is, you're telling me the point of intersection. So in a straight line, if I drew two straight lines, how many intersections can you get? One. That's why they call it unique solution. Okay? So the only time you don't have a unique solution, meaning that the only time that two lines don't intersect is when? When will you have two lines that don't intersect? Yeah. So if you find an equation anywhere where the solution, sorry, the gradient is the same, so if they both have the same x's, you're not going to have a unique solution. Okay, so if you rearrange it and they both have the same x's, then it's not going to give you a unique solution because they're parallel. Okay, so that's the only thing you needed to understand. Or you can try to solve it, and if your CAS comes back with no solution, just means there's no solution. Okay, if the CAS comes back with an answer, then you have a unique solution. So one of the ways is you can, this is a VCA question 2006, you can do that for each and every one of them and try to solve in your CAS, but it takes a long time. If you